Walk me through it. How'd you do it? Whoa. Hold on. Yep. So you did A equals 1, B equals... Uh-huh. Okay.
And then I since it's the B term, I did what plus what equals -6.
Yep.
And then what times what equals 9.
Okay.
And since the B term is negative, that means they're both going to be negative.
Okay.
So I got -3, so -3 times -3 equals -6.
Yep.
And then 3 times -3 equals 9.
Perfect.
And then I did y minus 3 since they're negative. And then since it's the same thing, I just put I
Yeah, so you wrote it y minus 3 squared. Very good. Now, there was another way you could have done this problem. Did anyone do it a different way? Daniel?
I just took, let's see if it was like that they're perfect squares.
Very good.
Y2 and 9, which they are, so you just take down, what is the square root of y2? Y squared, which is y.
Mm-hmm.
And what's the square root of 9, which is 3. And then I looked at the sign on the b term, and then it's y minus 3, and then it's just going to be squared.
Very good. Now, before you can use that shortcut, Daniel, there is one more thing that you need to check.
Oh, that's right. You have to make sure they both equal, when you factor it, it equals 6y, right?
Good.
No, 2 times y times -3 equals -6.
Good. You had to make sure that this combined to give you 6y and check it with that middle term, and then use that negative to write it as y minus 3 squared. Okay? You guys, both of these methods are good. So if you forget the shortcut on the test, are you going to be out of luck? No. Okay? You'll still be fine if you know A, B, and C. Will the shortcut save you some time? Yes. Okay? And it's a good way to check some of your answers. Make sense? Why do you have headphones in? Okay. All right, so today what we're talking about, we're going to learn one last way to factor, and then we are going to be factoring problems completely. What that means is we are going to be factoring from start to finish and factor down until we can't factor no more, okay? All right, the first thing what we're going to learn is we're going to be able to factor by grouping. We've heard grouping before. Do you guys remember what grouping was? What do we use to group? Yes, it's when A was not equal to 1, right? We would group, right? And we grouped with parentheses, okay? Write a note for yourself. We are only going to group when we have 4 terms, okay? If we have 3 terms, we do not group. If we have 2 terms, we do not group. I will not give you a problem with more than 4 terms, so the only time we group is when there's 4 terms. Cool beans? All right, so this is what grouping looks like. Whenever we're given 4 terms, first thing you got to do is you got to check that it's in standard form, and then you group the first 2 terms with and then the second 2 terms. You factor out a greatest common factor. In this case, in the first 2 terms, their greatest common factor was x squared. It turned into x squared times x plus 3. In the second case, the greatest common factor was a 2, and it turned into x plus 3. You guys, your parentheses should match if you did it correctly, and then you can factor it into x plus 3 and x squared plus 2, okay? Can anyone tell me, why is x squared plus 2, why is that unfactorable? Why can't we factor that? Why couldn't we factor that any further? Daniel?
Because the x is squared.
Yeah, so there is no GCF, you're right. But if this was x squared minus, 4, we could factor it. What's different here?
It's a plus.
It's a plus, okay? So it's a plus, and the 2, is 2 a perfect square? No, so it's also unfactorable based on that, okay? Now, on your test, am I going to give you anything that's unfactorable? No, okay? I told you that since the beginning. All of your questions are going to be factorable, okay? But I do want you guys looking to see that this is unfactorable, okay? So at this point, we are done because there's nothing else to factor. What's up, Isa?
Wait, why is it x, when you factor it out, why is it x2 and not just x?
Because do you agree that the greatest common factor here was an x squared? Because they both had, one was x cubed and one was x squared.
Oh.
So we pulled out an x squared, okay? Let's see another example, okay? In B, How do I know that I need to group here? There's 4 terms, okay? It's that simple. Anytime there's 4 terms, we must group, okay? Now, don't group right off the bat. I told you guys, you need to make sure that it's in what form before you group? Standard. Is this in standard form? No, why not? XY. This needs to be in the front or after the x squared, okay? So let's rewrite it. So let's change it to x squared plus xy plus y plus x. Do you guys see how I just moved this term to the front? Is this now in standard form? Yes, because it's 2, 2, 1, and 1. You guys with me? Okay, now can I group it? Yeah, so group the first 2, group the second 2. What's the GCF of those first 2 terms? Daniel?
X.
Good, it's just x. Pull out an x. What's left over, peeps? Brandon?
Y plus X.
Yeah, x plus y or y plus x, okay? Okay. Can I factor anything out of the second 2 terms? No. So you're just going to put a plus what?
1.
1. Now, does this match exactly? No. But can I rewrite this y plus x as just x plus y?
Yep.
Yeah, because I'm not changing anything, right? So write it down as x plus y. And now, do my parentheses match?
Yes.
Yes, it's both x plus y, right? So my final answer is going to be x plus y. And what's my other term? What's my other factor? X plus 1. So guys, have we done grouping before? But have we done grouping to start factoring? No. And we use grouping to start factoring when, how many terms do we have?
4.
4, okay? What's up?
Is that it? We're
Completely factored, okay? Any questions on the second one? Let's try a third one, okay? A cubed plus 3a squared plus a plus 3. Now, comparing this to what we've seen in the past, do you guys agree we've never seen anything that was cubed, right? So now you already know, okay, it's definitely going to be hard to factor this using the ABC because we've never seen anything that's cubed. So whenever there's 4 terms, how do we factor it? Grouping, okay? Is this in standard form though?
yes.
Yes, okay? So we can start right off the bat by grouping. So group the first 2 terms, group the second 2 terms. Guys, what's the GCF of those first 2 terms in that first group? Asia? A squared, very good. So you're going to write down an a squared. And then what's inside my parentheses? Daniel?
A plus 3.
A plus 3. Now, in the second set of terms, the second group, what's the GCF, guys? It's just 1, okay? So you put plus 1. And then what's left behind?
The same A plus
A plus 3. Do my parentheses match?
3. Yes.
So my 2 factors are what?
8 squared plus 1. And
A squared plus 1 and a plus 3.
Wait, I have a question.
Yes,
Where'd you get the 1 from?
the 1. Okay, so whenever we can't factor anything out, we just put a plus 1. Because technically, if you distribute this 1, won't you just get a plus 3 again? So we just write the plus 1 so that we can write it as our answer later on. Okay? Yeah, Rocco? No. You could write a plus 3 times a squared plus 1. Yep. Adam?
Can you go to church? I have 3%.
Yeah. Any other questions? These are good questions, guys. Keep them coming. We're Gucci? Daniel, what's up?
Would it only be unfactorable if the A was squared and A plus 3?
Oh.
Because 3 is not fair.
Yes. So technically, right, a squared is a perfect square, right?
Yeah.
Is 1 a perfect square?
Yes.
Yes. So, but why can't we factor this one on the left? It's plus 1. Do you guys see that? If this was a minus 1, then we could continue factoring. Thank you very much for bringing that up. If this was a minus 1, then we could continue factoring. But since it's a squared plus 1, we cannot continue factoring. Isa?
What is the plus 2? Why can't we do
So, do you remember when we have a binomial, for example, a squared minus 1? Do you agree that we can turn this into a plus 1 times a minus 1 based on that shortcut that we learned? But it only works if it's a minus there, okay? Whenever it's a plus, we stop, we say that it's unfactorable, okay? Thank you, Daniel. What's up? Okay, D. Before I group, what do I need to do before I group? Sophia?
Put it in standard.
Standard form, baby. So how do I change this into standard form?
Well, you have to put y2 in the front, and then you have the 2x, and then the wait. You have to put yx,
Good.
and then 2x, and then 2y.
Good. Absolutely right. Okay, now can we group? Yup. Why am I grouping here? Brandon?
There's 4 terms in the standard form.
There's 4 terms, okay? And it is in standard form. Okay, what is the GCF of the first 2 terms? The first group? Y. Very good. So factor out a y. You're going to get y plus x. Yes? What can I factor out of the second 2 terms? Bruno? A 2. And I'm going to get x plus y, right? Can I just write that as y plus x? Do you guys agree with that? So I'm going to write y plus x just so my parentheses match. Do you guys see that? So now the y plus x matches the y plus x. My 2 factors are y plus x and what?
Y plus 2.
Y plus 2. Can I factor this anymore?
No.
No. This is the final answer. Yep. Mm-hmm. Yeah. All right, so we're Gucci? Yeah.
Why does it have to be in standard form?
It has to be in standard form because then if you factored when it wasn't in standard form, I want you to try it as well. You'll get that the parentheses won't match each other. Okay? And you won't be able to factor any further. All right? Good questions. Any other questions? Okay. Moving on. So, factoring polynomials completely. Okay? So, this part of the lesson is pretty much, it's nothing new, but it's taking everything that we've learned and putting it all together in a 4-step process, okay? Take a look over here. The steps are more detailed over in the core concept, in the concept summary area, but this is like the general checklist for you. First thing that we look to factor out is what? GCF, okay? That's standard. We should already be doing that, right? Second thing we look for is we look if there's any squares. Do you guys remember when we were checking if the first and the last term were perfect squares? We could apply that shortcut. That should be what you do second in these scenarios. Third is you look, okay, if they're not perfect squares, then we have to use A, B, C, right? We set A equal to something, B equal to something, and C equal to something, and you factor based on that. Please cross out binomials and put trinomials. Okay? That's when we have a trinomial and we have A, B, and C. And then your last resort, if none of those work, is to group it. Okay? And grouping happens when we have how many terms?
Bless you.
Cuatro. Okay?
Bless you.
Bless you. Sure. You're going to use these steps to solve the final questions on this lesson. Now, you guys, you have to, I don't care how hard you've been working in the past, how hard you've worked in this chapter, these 4 from this lesson need to get memorized. The order matters, okay? So for your test on Friday, 1, 2, 3, and 4 need to get memorized. Are we cool? You'll have them memorized by Friday? Yes. You promise me? Yes? Okay. All right. So check it out. In this example, okay, what was step number 1? GCF. What's the GCF of these 3 terms? Or do they have a GCF?
No.
Brandon? 3 and x. Some of you said 3, some of you said x. You have to factor out both of them, a 3 and an x. So factor out a 3x. What's left over? Brandon?
X to the second plus x to the second, no, plus 2x to the second minus 3x. No, wait, 6x. Minus 6x.
Very close. Veronica?
So
Correct. Don't forget, we factored out an x, right? So we have to factor out an x from every term. So it's just going to be x squared plus 2x minus 6. You guys with me? Okay. What was step number 2 in my checklist? Squares. Is my first term a perfect square? Is x squared a perfect square?
Yes.
Yes. Is 6 a perfect square, though?
Yes. No.
No. Is 4 a perfect square?
Yes.
Yes, because 2 squared is 4. What's 3 squared? 9. Did we hit 6 in between going from 4 to 9? No, so 6 is not a perfect square. So we already are like, okay, step number 2, we've done it, we've checked it, we can't use squares. So what was step number 3? Trinomial.
A times C.
A, B, and C. What's A here?
1,
What's B?
2,
And what's C?
6.
Negative 6. Okay? Now, we do not multiply A and C because we're dealing with A equals 1. Do you guys remember that method? It's a little bit faster. We're just looking for two numbers, and when you add them, they give you 2. But when you multiply them, they give me what?
Negative 6.
-6. Are there two numbers that when you add them, they give you 2, but when you multiply them, they give you -6?
Yes.
What numbers? -2 and 4. But those would multiply to give me -8. You guys, these, it doesn't exist. It doesn't work, okay? Now, I'm going to be upfront with you guys. I will not give you a question like this because everything I give you on your test is going to be factorable, right? But this is unfactorable. And I want you to write that down. So if it's unfactorable, that means that we stop right here. This is our answer, okay? We cannot move on because we can't factor any further, okay? Yeah, Ronnie?
Wait, when do you do when you multiply the A and C?
When A is not equal to 1, okay? Guys, will you see something like this on your test? No, okay? So everything else that we do will be factorable, so that's fair game. But something like this, everything that I give you will be factorable. Yes?
So if the plus is always positive and the times is negative, it'll never be factorable.
Not necessarily. Because what if this was a 1? Right? Couldn't you have 3 and -2 as your factors? Okay? The reason that it's unfactorable is because this was a 2. And there's no, the only factors of 6 are 2 and 3 and 1 and 6, right? And the difference between any of those two is either 1 or 5. Yeah.
So if you can continue factoring, you would solve it normally, right?
Correct. Mm-hmm.
3x. When would you add that?
So we'll do some where we factor even further, okay? All right. B. What's step number 1?
GCF.
GCF. What's the GCF here?
7x.
7x squared. Why is it squared, peeps?
Is 4 and 2.
Because it's 4 and 2. Do you guys see that? So we can factor out a 7x squared. You guys, what's inside the parentheses then? Bruno?
7x squared.
X squared
-4.
minus 4. Yes? Okay. Oh, what's up? But we factored out both of the x's and x squared. Do you see it now? Okay, so now what's in blue, we have to check what? What was step number 2? Squares. Is this a set of perfect squares? Yes, x squared is a perfect square and 4 is a perfect square. So we're going to use that shortcut. Does anyone remember the shortcut? Daniel.
You just take the square root of x squared and the square root of 4, and then you take the sign, and then it's just going to be x minus 4. And x minus 2.
7x squared, and this is going to be x minus 2 squared?
Yes. No, wait, no.
Close.
It's going to be x minus 2 and x plus 2.
There we go, okay? It needs to be x minus 2 and x plus 2. Do you guys remember, when you square a binomial, right? When we have x minus 2 squared, we're going to have a middle term. Do we have a middle term here? No, so it has to be sum and difference. Do you guys remember that? So this one has to be sum and difference. So this is now completely factored. Yes? Questions? All right, let's do C.
Wait, and that's it? That's the answer?
Yep, that was the answer. It should have been 7x squared, x minus 2, x plus 2. All right, C. What do I do? Daniel?
Check for the greatest common factor, which is 3x.
Good. 3x.
In parentheses, you'll have x squared minus 4.
Mm-hmm.
And then you'll check for the squares, which it is. So it's going to be 3x in parentheses, x minus 2, and x plus 4. I mean, x plus 2.
Good.
That's your
So the reason I went through this one pretty quickly was because we just factored x squared minus 4, right? And that factors to x minus 2 and x plus 2. Okay? Any questions on this one? No? All right, let's try D. All right, in D, what do I look for first? GCF, baby. What's the GCF here? Isa?
2y.
Good. It's 2y. And once we take out a 2y, what's left over, peeps? Brandon?
Negative 6y plus, no wait, it's y minus, y to the second minus 12 minus 6y, then plus 9y.
X. Excellent. Okay. Every single y that was there before, do you see how it's decreasing by a power? It's going down by 1, right? It's exponent. So this cube becomes squared. This squared becomes to the first power. And this y to the first becomes y to the 0, which is just 1, right? Because you're factoring out a y. You're also factoring out a 2. So 2 divided by 2 becomes 1. 12 divided by 2 becomes 6. And 18 divided by 2 becomes 9. Do we all see that? Okay, so if we keep going, now what's the second thing we ask ourselves? Janessa? Perfect squares. Are my first and last term perfect squares? Yes. So let's write it down. What's the square root of y squared? And what's the square root of 9? 3. Now you have to check one more thing before you can use the shortcut. Who remembers what it was? Brandon?
2 times y plus 3 equals 6, negative 6y.
Good. 2 times y times 3 will give me what?
Negative 6y.
6y. Does the 6y match the 6y? Yes, okay? Now, you said negative 6y. Remember, we don't care about the sign until the very end, right? So my two terms are going to be y and 3. Now we check the sign. What goes between them? A minus sign, okay? And it's y minus 3 squared. Do you guys see the difference here? This is squared because we have a middle term. If there was no middle term, it would be y minus 3, y plus 3. Do you guys see the difference? Okay? You need to be checking for that. So when there's a middle term, it's a binomial squared. When there's no middle term, it's going to be sum and difference. Okay? And this is my final answer. All right, let's do E. M cubed minus 2m squared minus 8m. What do I do? Greatest common factor. Very good, Zach. What is the greatest common factor here?
No, squared.
Okay. Why is it not 2m, Zach? I know. I'm glad that you said that though. But why can't we pull out a 2 here? Good. The m up here, its coefficient is 1, right? So you can't factor out a 2 from a 1. So you're just going to factor out an m. Zach, what's left over after that?
M squared and 2m, m negative 2m, and 8 negative.
Good. What do I check second? Brandon? Perfect squares. Is this a perfect square example?
No,
Why not?
because 8 is that
8 is not a perfect square, okay? 9 is the closest perfect square to 8, but since 8 is not a perfect square, what do I do when I'm not dealing with perfect squares then? What do I do when I'm not dealing with perfect squares? Cody? Good. So what do I need to do? Good. Okay? So how can I factor knowing that? Good. Did you figure out the factors?
Oh yeah, it's -4 and 2.
Excellent. It's -4 and +2. Yeah, Sophia?
When you're trying to find out where the A, B, and C is, do it with the ones that you just distributed from?
Yes, exactly. So once you factor out the greatest common factor, you're going to kind of like ignore this m until the very end. It's going to be part of your final factored answer, okay? But now we're just looking at what's inside the parentheses if we can factor that any further, okay? All right, so very good. So what do I do from here? What do I do from here? Bryson?
Make the parentheses.
Good. So it's going to be m, and I have to factor this red expression into two different factors. What are they?
Negative.
Go ahead.
-4 minus 2. Wait, no. Wait, m, isn't it m to the second or something like that?
Oh. So remember, if a was not equal to 1, I agree we would have to write it out and then group it. But when a is 1, our method becomes way easier. These are just both of our factors, right? Cody, how do I write it?
M squared
Interruption, Connor Bove,
minus
please report
4m.
to services. Connor Bove, please report.
The method that you guys were thinking of was when a was not equal to 1, right? And we had to write it all out and then group again. Do you guys remember that? We don't have to group here because a was equal to 1. So it's just m minus 4 and m plus 2. And this is our final answer. Sophia, do you see how there's an m in front? Okay? That's the reason why we need that m out in front to begin with. Okay? Are we good? Okay. Now, the only thing we're adding is an equal sign, okay? So this is where we set it equal to 0, and at the end we get a bunch of different roots, okay? All right, so check it out. We've got 2x cubed plus 8x squared equals 10x. Remember, you don't start factoring until what? One side needs to be equal to 0. So what would you guys do to make one side equal to 0? Issa, what would you do?
I would subtract 10x.
You are 100% right. Subtract 10x from both sides. So we are going to get 2x cubed plus 8x squared minus 10x equals?
0.
Now we have 0. Do you guys see that? Super important. Don't factor until you have equals 0. Now we can factor. What do I check for first, people? Don't check for A, GCF, okay? Now the same 4 steps apply. We cool? So what can I factor out of all 3 of these terms, Shayla? 2x. Factor out of 2x, you're going to get x squared plus 4x minus 5. You guys with me? Okay. Now, that middle that term in parentheses, we need to also look to factor. Can you factor it based on squares?
No,
Why not?
because
5 is not a perfect square. So, step number 2, we don't do. We don't factor it based on squares. What do we move on and do? A, B, and C. Okay? So, A is
X, or 1.
1, B is, and C is. You guys with me? Okay. I need 2 numbers that when I add them, they're going to give me 4, but when I multiply them, they will give me -5. Ronnie? 5 and -1. So this is going to factor. It'll be 2x. What are my two factors now? From the original parentheses. Adam, what'd you get?
I got x2.
Good. X plus 5 and x minus 1. Is there anything else we can do to factor this? Yeah? What else? We're going to leave the 2x for now because we factored that out in the beginning. Ah, very good. So we set it equal to 0 after it's completely factored. Do you guys agree this is completely factored?
No.
No, it's not?
No.
What else can we factor?
Only doing the parentheses like all of the x plus 5 equals 0 and x minus 1 equals 0?
Correct, but that's not considered factoring. You're absolutely right. That's considered solving it, okay? So now it's completely factored, right? There's nothing else we can pull out from any of the terms on the left. Agreed? So now we set each of these equal to 0. So 2x, we set equal to 0. We set x plus 5 equal to 0. And we set x minus 1 equal to 0. How many answers am I going to get? 3, okay? So 2x equals 0. Guys, I'm going to go over this one time and hopefully one time only because I saw some of these mistakes on our quiz, okay? We would divide both sides by 2. Do you agree? What is 0 divided by 2? It's 0. Is it 2? No. Please do not put 2 as your answer there. Are we cool? All right. How would you solve x plus 5 equals 0? Daniel?
Subtract 5 to both sides.
Yep.
And then dx equals -5.
Good. And the last one, Cody K, what would you do?
Add 1 both sides.
X equals? All right. I've waited this long. I can show you guys a little shortcut, okay? Not a shortcut, but like something to look forward to. What was the highest degree at the beginning of our problem? 3. You're going to have 3 solutions. How many solutions do we have? 1, 2, 3. Cool?
Yeah.
Okay. So if our highest degree was x squared, how many solutions would we get? 2. Yeah, Brandon?
What would you do with the highest degree like 10?
Then you would get 10 answers. Do you think I would give you something like that?
Even if
I won't, I promise.
Even if it was just like 2x to the 10th power plus 8x, and then you still get 10 answers.
You'd still get 10 answers. Yeah.
So on the test, you'll put in the directions that you have to factor completely, right, compared to just factoring how you learned.
Correct. It'll say factor completely or just factor. And essentially they're like very similar, but they're different types of questions. We'll see more detail what the test is going to look like. Okay? All right. B. What do I do? Isa? Why can I start with GCF here? It's already equal to 0. Very good. Okay? So what's the GCF? W. We've got w squared minus 8w plus 16. Yes? What do I check for next? Isa? Squares. Is this a perfect square? Is this a perfect square? Yup. So the square root of w squared is what? What's the square root of 16? What do I do next? Brandon?
You put w minus 4 squared.
I agree with you, but we forgot to check one more thing from our trinomial. Daniel?
From the trinomial?
Yes. Before we can use the shortcut, there's one more check that I need to do. Bruno?
You gotta multiply -2.
Good. 2 times W times 4 should match 8W. Remember, the negative will come second. Does 2 times W times 4 give me 8W? Yes. So those two check out. So now the minus, right? It's useful because it goes right here. So it's W minus 4 squared. Do you guys see that? And this is all equal to 0, right? Is there anything else we can factor? Brandon? No. Okay, it's completely factored. So what do I do when it's completely factored? Good, you set it equal to 0. So W is going to be set equal to 0, and W minus 4 is going to be set equal to 0. Now, technically there's two of them, right? So W minus 4 also equals 0. Again, okay? How many answers am I going to get? 3, right? One of them is going to be repeated, though. Do you guys see that? Because one of them was W minus 4 squared, okay? So W equals 0, that's one answer. You would add 4 to both sides, get W equals 4, and then you would get W equals 4 here as well. Yep.
Would it be wrong if you wrote it once? Just
No.
leave it?
No. So your answers should only be 0 and 4, right? I'm going to write it 3 times because in the beginning I told you we would have 3 solutions. Right? What do we call when it's used twice, when we have the same answer twice? Very good. It is a repeated root. Excellent. Which one is the repeated root, 0 or 4? 4, right? Okay, any other questions? Yeah.
Would we get points off if we wrote like W minus 4 to the second? Or
W minus 4 to the second. No. No. So if you only wrote W equals 4 and W equals 0, you're fine. Okay. C. What would you do, Daniel?
Greatest common factor, so x,
Mm-hmm.
and in parentheses you put x squared minus 5 equals 0.
Okay.
Then you check.
Oh, wait. Should this be 25?
Yes.
Yeah.
No, it should be 5 because greatest common factor.
Yeah, but the first one, the first term has a 1, right?
You're just getting rid
So, what do we check after GCF? What do we check after GCF? The squares, very good. So, is x squared a perfect square?
Yes.
Yes. Is 25 a perfect square?
Yes.
Yes. So the square root of x squared is x. The square root of 25 is 5. So what is x squared minus 25 factor to? Brandon?
X on the outside of parentheses, x minus 5 parentheses equals 0.
X minus 5 squared?
No, it's a plus or minus.
Thank you. Okay. It should be x minus 5 and x plus 5. Do you guys see the difference between these two shortcuts? One is where we're missing the middle term. One is where we have the middle term. Yes? Okay. So, what do I do from here? Yeah, solve it. Set each of them equal to 0. Because, do you agree, nothing else can be factored? So we just say, all right, x equals 0, x minus 5 equals 0, and x plus 5 equals 0. X equals 0 is already solved. You just add 5 to both sides. You would get x equals 5, and you would get x equals negative 5. Yes? Yeah, Brandon?
On that, that's where you get points off if you read like x equals plus and negative 5.
No. As long as you have those 3 answers, I'm happy. You showed your work. All right, last one. You guys do it on your own. See if you can figure it out. So, how did we start this problem? Yeah? GCF, baby. So, when I pull out my GCF, how do I write it? Brandon?
X parentheses x to the second minus 7x plus 12.
Beautiful.
0.
What do I check after that? Squares. Is x squared a perfect square? Yes. Is 12 a perfect square? No. So can we use the squares shortcut? No. What do I do if I can't use the squares shortcut? Trinomials. So that means A, B, and C, right? What's A?
1,
What's B?
-7,
And what's C?
12.
So I need two numbers that when we add them together, they give me -7. But when I multiply them, they give me 12. What two numbers belong there, Sophia? -4 and -3. We Gucci? Okay, so what is my final factored expression? Isa? Excellent. Is this completely factored? Yes. So now I set each of them equal to 0. So x equals 0, x equals 4, and x equals 3. Gucci? Any questions? We will finish the exit ticket and the word problem tomorrow. Turn these in.